So for problem 1, before we look at an integral, we want to remind ourselves, how do we properly take the derivative using the chain rule? So the outside function here is sine. So remember, the first thing we do when we want to take the derivative using the chain rule is we want to take the derivative of the outside function and leave the inside intact. So the derivative of sine is cosine. So just leave the inside alone. Then we multiply that by the derivative of the inside function. Now let's see how to evaluate this derivative by using sort of the guess and check. So we can see here that this is our f of g of x, and this is our g prime of x dx. So I can let g of x be our u is 2x, u is our x squared plus 5x, and u prime is 2x plus 5. So now if I rewrite this integral in terms of a function of u that I've just created, I get the integral of cosine of u du. So I've just replaced let's not call that u prime. So if we look at our integral, cosine of our u, right, times all of this together is our du. So now I have a much simpler integral that I can use. So the antiderivative of this is sine of u plus c. And so now we plug back in what u stood for. U was sine of x squared plus 5x plus c. So this is what we would consider sort of guessing, right? And then we can check it by taking the derivative. And I can actually see that this matches what I started with here, and I've already taken the derivative, so I already know that if I take the derivative, right, this works out. So let's look at number 2. Number 2 says take the derivative of the natural log of 9 minus x squared. So the derivative of the outside, right, is just something over 9 minus x squared. And then we multiply by the derivative of the inside, and I get negative 2x. So this is the derivative of this function. Now if we look here, we want to integrate this, and this is kind of close to the derivative of that function. The only thing different here between what's inside this integral and this derivative is the negative 2. So if I try to guess, right, I can say, well, if I multiply my integral by a negative 1/2 out front, and then because I'm multiplying the denominator by negative 2, I also multiply the numerator by negative 2. Well, now I can see that what's inside this integral matches the derivative of this function. And I can say, well, this is negative 1/2 times the natural log of 9 minus x squared plus c. I can check it by just calculating the derivative. So negative 1/2, we already know the derivative of that is negative 2x times 9 minus x squared, and when I cancel my negative 2's, I get back exactly with what I started with in the integral.